Good day, student. I just want to start with a topic which is rate of reactions for grade 12 AS level chemistry. As I said, the topic is rate of reaction. What does rate of reaction mean? The speed of different chemical reactions varies greatly. Some reactions are very fast, others are very slow. The speed of reaction is called rate of the reaction. What is the rate of these reactions? If you look at the diagram, you see this roasting, baking, explosion. Roasting is very slow, baking fast, explosion very fast. Right now, some reactions take place instantly, but most are much slower, and it's possible to measure how long this reaction takes to reach a certain stage. As a chemical reaction proceeds, the concentration of the reactants decreases and the concentration of the product increases. The decrease in the concentration of reactant per unit time, or the increase in concentration of product per unit time, is known as rate of reaction. The study of rates of reaction is known as kinetics. Look at the formula. Reaction rate equal to change in amount or concentration divided by time taken. Rate equal to change in reactant concentration divided by change in time, or rate equal to change in the product concentration divided by time taken changes, or the disappearance of reactant divided by time taken, or the rate can be defined as appearance of products divided by time taken. The reaction rate is positive quantity. The rate of reactions. Why are some reactions faster than the others? This illustration contains several discussion points relating to reaction rates, including red characters. These represent particles that have a large amount of kinetic energy, and therefore they are likely to react. Blue characters, these represent particles that have a small amount of kinetic energy and therefore unlikely to react. Hence, while some are asleep, these ones that have amount of kinetic energy, the red characters, bombast gas, collision between two bombast gas, represent a large amount of energy released during a reaction. Okay. Let's look at the simple collision theory. How do chemical reactions take place? Substance in the liquid, aqueous, gaseous phase consists of particles in rapid and constant motion. The rate of chemical reaction depends on three factors. 1. The collision frequency. If a chemical reaction is to take place between two particles, they must first collide. The number of collisions between particles per unit time in a system is known as collision frequency of the system. The collision frequency of a given system can be altered by changing the concentration of the reactant, by changing the total pressure, by changing the temperature, or by changing the size of the reacting particles. The second factor is collision energy. Not all collisions, however, result in chemical reactions. Most collisions just result in the colliding particles bouncing off each other. Collisions which does not result in a reaction are known as unsuccessful collisions. Unsuccessful collisions happen when the colliding species do not have enough energy to break the necessary bonds. If they do not have sufficient energy, the collision will not result in a chemical reaction. If they have sufficient energy, they will react and the collision will be successful. The combining energy of the colliding particles is known as collision energy. Not all particles in a given system have the same energy. Some have greater energy and some have lower energy. Because they collide in a process, they collide with each other and they collide with the wall of containers. They have a broad distribution of different energies. The shape of the distribution of energy depends on the temperature of the system. The higher the temperature, the greater the main kinetic energy of the particles. Distribution of molecular energies at a characteristic temperature can be represented graphically. This is known as Maxwell-Boltzmann distribution, whereby you can say the probability and kinetic energy, most probable kinetic energy and the average kinetic energy. Since the curve shape is not symmetric, the average kinetic energy will always be greater than the most probable. At higher temperature, the distribution of energy will be different. The main energy will be higher and distribution will be broader. You can see the graph. Note that area under the curves should be constant since total probability must be 1. The greater the main kinetic energy of the particles, the greater the collision energy. First is activation energy. Before we go in there, slower and slower, reactions do not proceed at a steady rate. They start off at a certain speed, then get slower and slower until they stop. As the reaction progresses, the concentration of reactant decreases. This reduces the frequency of the collision between particles, and so the reaction slows down. There's a collision between the particles of reactants forming products. Changing the rate of reactions. Anything that increases the number of successful collisions between reactant particles will speed up a reactions. What factor affect the rate of reactions? Increased temperature, increased concentration of the dissolved reactants, and increased pressure of gaseous reactants. Increased surface area of solid reactants. Use of catalyst. Activation energy The minimum energy colliding particles need in order to react is known as artificial energy. If the collision energy of colliding particle is less than artificial energy, the collision will be unsuccessful. If the collision energy is equal to or greater than the artificial energy, the collision will be successful. A reaction will take place. The artificial energy can be changed by addition of catalysts. In summary, in reactions that do not happen instantaneously, most collisions are unsuccessful. Such reactions can be made faster in two ways. One, by increasing the collision frequency. The more frequently the particles collide, the faster the reaction will be. Two, by increasing the fractions of successful collisions. The greater the fraction of collision that result in chemical reaction, the faster the reaction will be. The fractions of successful collision can be increased by increasing the collision energy or decreasing the artificial energy. The fraction of successful collision can be shown graphically as the area under the curve to the right of the artificial energy divided by total area under the distribution curve.
Attention, learners. We invite you to watch our YouTube tutorial video carefully. After watching, we kindly request you to answer the questions added to the video. Don't forget to hit that like button and subscribe to our channel for more exciting videos. If you have any questions about the questions or need answers, please leave a comment, and we'll be glad to assist you. Happy learning and thank you for your support.